Okay, next up I'm being asked for the power of a quotient property. And that just states that a to the power of n over b to the power of n is equal to a over b all to the power of n. Let's just go through some examples to prove that this is true. For our first one, we have 2 cubed over 4 cubed. When I express that out, that is 8 over 64. And this is going to be 8 over 8 by 8, which is 1 over 8. If I had used this form, that would become 2 over 4 cubed. 2 over 4 can be simplified to 1 over 2 cubed. Apply those cubes independently, and it'll become 1 cubed over 2 cubed, which is 1 over 8. So this equality does hold. Let's just do a couple more. Let's try 4 over 2 cubed. That's going to be, squared. Now apply those. That becomes 4 squared over 2 squared, which is 16 over 4. That is 4 by 4 over 4, which is just going to give me 4. This is the same as if I had 4 over 2 is the same as 2 squared, so 2 squared, and that is indeed equal to the 4. So obviously you can tell that the equality does hold, and that this property is true. Let's try 3 over 2 squared. That is going to give us 3 squared over 2 squared, which gives us 9 over 4, which is the exact same thing as if I had, as I've said here, 3 squared over 2 squared. And so it's just used to, typically in algebraic expressions, when you have to like simplify it down, where like you'd be given x to the power of 4 z squared over y to the power of 3 all squared multiplied by multiplied by y to the power of 7 over x cubed as an example, and you'd be told to simplify it. And so first I'm going to apply the power of a quotient property to multiply all of these powers by that 2, and that's just based off of the fact that x to the power of a all to the power of b is x to the power of a by b, because it's not just a 1 in that place. And so applying that, I would get x to the power of 4 by 2, z to the power of 2 by 2, over y to the power of 3 by 2, multiplied by y to the power of 7 over x cubed. This gives me x to the power of 8, z to the power of 4, over y to the power of 6, y to the power of 7 over x cubed. Now I'd like to simplify this down. I'm just going to use the fact that x to the power of a over x to the power of b is the same thing as x to the power of a minus b, and apply that where I see commonality. So I have 2 x's here, and I have 2 y's here that I'm going to apply this with. And so from this, I will get x to the power of 8 minus 3, z to the power of 4, and y to the power of 7 minus 6, leaving me with x to the power of 5, z to the power of 4, y to the power of 1. And that's the simplified version of all of this. And so its best use is in simplifying algebraic expressions.